For the rubber sheet geometry section, I recorded some of the answers to some of the problems, and I'm going to assume as you're viewing this that you have the book to see some of the images, at least the beginning images as well. For number 6, the theta curve is this particular shape. And the question is asking you, are there 2 points on the theta curve that will break it into 3 pieces? Hopefully the answer is pretty obvious that yes. If you use these 2 points, you'd have a top part, a bottom part, and a middle bar across 3 separate pieces. Is this equivalent by distortion to a circle? Well, if you use the same kind of spots to cut, you realize, well, you missed the 3rd piece. Any way that you have 2 points other than side by side, when you will separate the circle into 2 points and you can't get the 3rd point. So the theta curve and the circle are not equivalent by distortion. For number 7, when you're comparing the alphabet, the font is important with this. When you're setting this up, things such as the K in English can be with different fonts, be 2 different looking characters. This group is assuming a font similar to the kind I'm using that you see the answers on here. When doing this kind of thing, probably the easiest thing to do first is look for the ones that have holes in them, because that will eliminate the other ones and make sorting through it a little bit easier. So you realize that A and an R from group 1, from group 2 the B, from group 4 the D and the O, and from group 8 the P and the Q all have circles in them. So these will be groups that are and be separate from the other ones that do not have holes in them. So looking at it, we just quickly compare. B, group 2, is the only one that has 2 holes in it. So it's going to, since there's no other with 2 holes, it'll be in a group by itself. The D and the O basically are equivalent by distortion to a circle. There's nothing that goes out from them like in the other groups with holes in them. So they're in a group by themselves. If you look then at group 8, that's basically, the P and the Q are basically a hole with one thing going out from them. Well, that puts them in a group. The group 1 you could basically make into a circle with 2 things going out from the circle. So that puts them in a group as well. If you use the point test to remove the same number of points, you should get the same number of pieces for all of these. The rest of them then, if we notice group 3 is a lot of them, group 3 is made up of ones that basically, if you grabbed each end, the beginning and the end of the letter and stretched it, you could stretch it into a straight line, so they would all look like the letter I. Then, if we look at group 5 and 7, group 7, hopefully you see rather quickly that with putting a dot in one spot, it separates it into 4 pieces with the letter K and X. So that leaves group 5, and these are equivalent to each other. One way to think about it, the E and the F are equivalent to each other. You could imagine just taking the bottom bar of the E and moving it straight down to make it look like kind of an elongated letter F. Excuse me. If you look at the F and the T, you think, well, with the T, if I took the bar up top, if you broke it in half, if you took the left half and stretched it straight up so it's aligned with one thing dangling out, you can do the same thing with the F. Take the top bar, flip it up to the top, and it has one thing out. You can do the same with the E, of course, except you flip the top up and the bottom bar down. And of course, the letter Y, you could just grab the top of the Y and the bottom of the Y and stretch it in a straight line, and the other bar would be out as well. So hopefully that gives you an idea of how to approach this and look at this. So that kind of puts them into groups, and then do the removal of 2 points, or 1 or 2 points, just to make sure that you've got them grouped correctly. With group 5, you can put a dot in strategic locations that you end up getting 2 or possibly 3 pieces, depending where you put the dot, and you can do that consistently for each of those. For example, for the E, to get 2 dots, you can put it at the top of the E on the left side, and you have the bottom part and just the top bar. You do the same point for F. Put the dot on the lower than the top bar of the T, and you have 2 points. And same with the Y. Put it on the towards the bottom of so you get just the bottom, and then it would look like a V shape beyond that. To get 3 points with the E, you just put it on the bar and the middle one, so that you got a top part, bottom part, and a middle bar. And of course, then the F would work the same way. At the T, just put it at the very with the top bar and the bar going up across, and the Y, put it at the intersection of the 3 different points. So we can see, using all of these tests, we can group them like this and find which characters are equivalent by distortion to each other. For number 9, take a coin with a hole in it, maybe like a Norwegian kroner. What they're doing is simply going to stretch the material, make it thicker and thicker, and stretch the hole bigger and bigger. And then once you get it to the thickness, or the thickness that you want the pipe to be, then just keep stretching it. Again, this really shows that this kind of material is an extremely stretchable and pliable. We do not have this kind of material, does not actually exist, but it exists in our imagination. So we can imagine that this is possible, that the 2 are equivalent by distortion to each other. For number 10, again, this very stretchable material, we do imagine that it's possible, and you can pause the video and look at this to see how number 10 worked. With the picture from number 17, when I did it and looked at it and said, well, the ones that have holes in it and have 1 hole in it will be equivalent by distortion to each other. That made it a good start. So we started with the donuts, spoon with a hole in it, 2 cups with handles. They have a hole in it. Even though the part of the cup where you pour the drink in, it's not actually a hole. You could scrunch it down into a round disc kind of thing, and it doesn't make a second hole. There's a shape in the middle that I'm not sure what that shape actually is, or that object is, but it has kind of a wooden handle and goes out with 3 metal things out to a round kind of blade looking like kind of thing. And you realize, well, that has a hole in the bottom, and then because of the handle, the sides going out, it looks like there's 2 or 3 holes on that object. So it immediately has more than 1 hole. And nothing else has more than 1 hole, so it's not equivalent by distortion to anything else. And then things that you can kind of collapse down into a disc shape, the cup without a handle, the 2 bowls, the plate, they would be equivalent by distortion to each other. The other objects are not really equivalent by distortion to each other at all. The rolling pin, as I look at the picture, I kind of think I see a metal pin going through it. So the handles, each handle has a hole in it, and the rolling pin part of it has a hole in it. And you've got this piece of metal going through it, so they're not really equivalent. It's not really equivalent by distortion to anything else. For number 21, this one technically has 2 different answers. If we start with the shape, what they did is they shrunk the tail down, and then the hole in the middle they just enlarged. Now, if this is a 2-dimensional shape, then you can't do the next step. In the next step, they're saying take the, let's see, what's it called here? It actually says it's rope. So I'm assuming it's 3-dimensional. But if you viewed it as 2-dimensional, they're not going to be equivalent by distortion. To get from the second image to the third, you have to lift the rope up into the 3rd dimension and over and down to the inside of the circle. If it's 2-dimensional, obviously you can't do this. So if it's a two-dimensional rope, they're not equivalent by distortion because you can't stretch it into the third dimension. However, assuming that it actually is a rope in 3 dimensions, then you can just lift it up over and put it over and into the inside of the circle. So then they made the circle large, and then that little rope part, the tail, just stretch it larger and larger till you got that shape. So while in 2 dimensions it's not equivalent by distortion, in 3 dimensions it is. Number 22, I don't have a picture for it. It's those holy spheres. They are going to be equivalent by distortion to each other. You can imagine that if this was really truly rubber, pliable, flexible kind of, both are made of this. The bottom rope through the sphere, you could slide up a little bit, and then take the bottom part of the very top, the top rope, take the bottom of that and stretch it down and around till it's below the one that you just moved up. So then you would have the one circle. Again, you can move it left and right, so you're not going through it. You just simply would move it, the top one, the bottom part of the top one around and down below the other one entirely. And of course, again, the bottom one you moved up to get it more towards the center. So then you could actually get that shape, and you just stretch them bigger. For number 23, you look at that shape. Excuse me. This is not equivalent by distortion. To get the hole, they're suggesting here take it around and put it against, but if you're putting it against it, that it becomes a circle, well, then you're gluing it together, and you cannot glue. So these two shapes are not equivalent by distortion. Number 24 is just kind of get to thinking. When you're doing this, if it's half full, and then you can somehow, the juice defies gravity and it moves up to the top half and not in the bottom half. Well, when that happens, there's some kind of hole in the middle of the bottom, right? It's not that it's solid down there. There's air in there, or a vacuum with nothing in it. So there's a hole there. The original shape did not have a hole anywhere. So these two are not equivalent by distortion. Number 25 I didn't do. Hopefully you could figure that out without too much problems. If you have questions, you can ask. Number 26, when we're working with these kind of shapes, probably the best way to look at this to say, since there are holes in it, to count the number of holes. If they have a different number, they're not equivalent by distortion. The image on the left, there's 5 holes around the ring. And you notice that there's a hole in the middle. So there are 6 holes. The image on the right only has 5 holes total. So it will not be equivalent by distortion. For these, there are other longer explanations, but realistically, counting the holes makes these questions 26 through 28 a lot easier. For number 27, we're starting with this shape, and we count up the holes, and we say that there are 5 holes in each. So it's likely that they're going to be equivalent by distortion. So to do this, they're suggesting that you take the original shape and then just kind of make it thicker. So the hole in the center becomes smaller and more round. And once it's thicker like that, then start squeezing around the circles to get the donut shape. So start making it smaller around the 4 things going out from the center, and keep making them smaller until you get that particular shape that you have there. So the two are equivalent by distortion. For number 29, again, we count the holes. And this is really kind of strange, but when you look at it, remember that this is extremely pliable and flexible material. It's not the kind that actually exist. So they're saying take the 2 end ones, take the left one, and just kind of slide it around the first hole, until it's on the bottom side of it instead of on the end of it. And then do the same with the one on the other side. Move it up so it's no longer on the side, but slide it till it's on the top. Now if you can do that, again with the one that's now on the top, if you slid it there, you can slide it over towards more to the left through the place where it joins together until it's on the top of the middle, or the middle one. And you can do the same with the bottom. Keep sliding it to the right. It goes through the first circle, through the place where it's joined together, over to till you're in the middle one at the bottom. Now you kind of have this particular shape, and they're saying you have the top and the middle and the bottom, but the left one's just a matter of twisting those circles until you get the shape on the end. So they are equivalent by distortion. For number 29, you have a hole. In the book we read about a hole in an inner tube, and one way to think about it was if you had this inner tube and you put your arm through the hole and stretched down to the bottom, had the hole at the top and stretched the whole way down to the bottom of the inner tube, grabbed the bottom and pulled it out, it would be inside out. Well, it's the same kind of thing, except now that there are two holes. So what they're saying is to take the darker spot is the hole. So take that darker spot and stretch it till it's over the entire top of the two-hole torus here, or double torus. Now, as you do that, the third picture kind of shows you, well, the hole through the center actually, if it's through the center, actually has to be kind of like tunnels. And so when you look at it from the inside, you see these kind of cone kind of shaped things that are the holes. Now, take that material and take the top edge, and it's like you would put your fingers in the hole and your thumbs on the bottom and push it up. Well, as you push up with your thumbs and pull the top edge down with your fingers, then those funnels would move upwards and be kind of like the arches that you see there. Again, they're still holes. And then you can stretch what was the top. As you pull it down, it kind of becomes the base or the bottom. They flatten it out. Well, and then just kind of keep going, pressing it down until it's in that original shape from before. But now the hole is on, well, they showed there, say they put the hole in the back where you can't see it. Well, that's what they chose to do. But again, in the picture, the darker showed you the inside, the lighter showed you the outside. So now, as you're flipping this over, you see that the darker is all on the outside. So what was the inside is now on the outside. And you can't see the inside. It's a lighter color. You can't see the original outside because now it's inside. So you keep making, from the second to last picture to the last one, you keep pulling it down and making what was the hole smaller and smaller until it actually looks like a hole again. And then they just chose to put it in the back for some strange reason. You can put it in the front and it would look exactly the same. It's just that the lighter would be inside and the darker would be on the outside.